A frog climbs onto a lily pad and leaps with a speed of 2.8 meters per second at an angle of 30 degrees, landing on the shore 6 centimeters above the surface of the water. How high up does the frog leap, and how far did the frog have to jump if he landed right on the edge of the shore? Let's start by labeling some of these values right on the picture. So we have this initial velocity of 2.8 meters per second. That is going to have a vertical component, VIY, and it's going to have a horizontal component, VIX. We know that this frog jumps here, right? And it's going to land on this lily pad. And we have the final height of 6 centimeters or 0.06 meters. We also know that this angle right here is 30 degrees. Okay, so question A, how high up does the frog leap, right? So we want to know, like here, this point, what is this delta y at the highest point? Okay, so for that, we can use the third equation of the big three, v final squared equals v initial squared plus 2a delta y, right? But we're going to specify that this is the final vertical velocity is the initial vertical velocity plus 2 times the vertical acceleration times delta y, okay? Well, we know by definition that once the frog gets here, the vertical velocity is going to be 0. That's true of any object that's rising and falling under the influence of gravity. So we can pretty confidently say that this is going to be 0. 0 squared is 0. But we don't know what the initial vertical velocity is, right? We need to find this. So let's do some trigonometry. I'm going to draw a picture. I'm going to imagine that I'm going to take like this vector right here, and then I'm going to move it over to this side and to make a triangle, okay? So my triangle is going to look like this. I've got the 2.8 meters per second on the hypotenuse. I'm going to have VIX at this leg, and then the 30 degrees here, and then the opposite to the 30 degrees is the VIY, okay? That means that if I want to figure out what VIX and VIY are, I can use sine and cosine. So by definition, I know that the cosine of 30 degrees is going to be equal to the adjacent over the hypotenuse. The adjacent to the 30 degrees is VIX. The hypotenuse is the 2.8 meters per second, okay? If I multiply by 2.8, I can find that VIX is going to be equal to 2.42 meters per second. I also know that the sine of 30 degrees, according to this, right, this triangle here, is going to be equal to VIY over 2.8 meters per second. That means that VIY is going to be equal to 1.4 meters per second. Okay, so I have that. I'm going to plug that in here. I'm going to square it. The vertical acceleration is negative 9.8 meters per second squared, and then I can now find delta y. So subtracting both sides by 1.4 squared and dividing by 2 times negative 9.8, I get that delta y at the peak is going to be 0.1 meters. So that's how high the frog is going to go above its jumping point. Okay. Now, what about how far? How far over is it going to go? So now the question is this: from here to here, what is this distance? That's called delta x. It's the range, okay? So delta x is v initial x times t. The frog moves at constant speed in the horizontal direction, so if we know its horizontal velocity and the time that it's in the air, we just multiply them together to find the delta x, the range, okay? I have VIX, I do not have the time. So I need to figure out how long the frog is in the air, okay? I'm going to take 2 steps to find the time. Okay, step 1, I'm going to figure out how fast the frog is going when it lands. So I'm going to find, like at this point right here, once the frog hits the lily pad, what is the final vertical velocity at that point? Okay, because that's going to be tied with, right, the range. If I know how fast it's going when it hits the lily pad, I can figure out the time, which means that I can then figure out the range. So what's that final vertical velocity going to be? Okay, so I'm again going to use equation 3, as I did before. Only now my delta y is not going to be at the peak of the frog's jump. It's going to be at the lily pad once it reaches the lily pad. So the initial vertical is still 1.4 meters per second. I'm going to square that. Still going to accelerate at 9.8 meters per second squared. But now my delta y is 0.06 meters, right? That's this value right here. That's how high it is when it hits the lily pad, okay? So this means that v final y, right, multiply that out, take the square root, is going to be negative 0.88 meters per second. And now that I know how fast the frog is going just when it hits the lily pad, I can figure out how much time it takes for the velocity to go from this initial vertical to the vertical velocity at this moment. Okay. So the time is going to be found from this equation, right? So the final velocity just before it hits the lily pad, so we're talking vertical, right? Vertical direction, is going to be equal to the initial, which was 1.4 meters per second in the vertical direction, plus negative 9.8 times t. So the amount of time it takes for the velocity to go from positive 1.4 to negative 0.88 is 0.23 seconds. Okay, now that I know the time, I can just plug that in here and finish out my problem, okay? So now the initial horizontal velocity I got over here, right? 2.42 meters per second. So it's going to travel at 2.42 meters per second for 0.23 seconds. And I get that the range is going to be 0.56 meters. So that is it for that question, right? That's how far away the frog jumps horizontally when it hits the edge of the shore.